Hello friends, today we are going to discuss a question on PDA, push down automata. So the question says construct a PDA for the following grammar and we are given with the rules for the context free grammar. So first of all we have to understand if the given grammar is in GNF or not in GNF. GNF is Grabrish normal form. So how to understand if the grammar is in GNF or not? So for that we should have the rule like which says like a non-terminal which is denoted by the capital letter, it should always produce something in the form of a terminal and then any number of variables, or you can say non-terminal. We are denoting it with V star. So here we can see if we destructure these rules, so we can write them as S produces A S A, or S produces B S B, or S produces A, or S produces B. So these are the rules which we have destructured. These were earlier written like this. You can also write them like this or like this as you wish. So here we can see in the very first rule that the capital S, which is a non-terminal or a variable, it produces a small a, then capital S, then small a. So we are having this terminal here. Okay, it's fine. Then it says a combination or any number of variables or non-terminal. So here we are having a variable. Okay, it's fine. After that we should never have a terminal, but here we are having. So we can say that this grammar or the production rules which we are given with is not in the GNF. So these are not in GNF. So whenever we are given with such rules or a context-free grammar which are not in GNF, so now let's see how to write the rules or the transition functions for the grammar which are not in GNF. So the rule is like this. On the left hand side, you have to mention these three things. First is the present state, in whichever state you are currently. After that, the input symbol, I'm denoting it with I/P. Then the top of stack, it produces means now I'm going to write the RHS or the right hand side. So it should contain two things. The very first thing is the next state on this whichever state we are moving to, and then the combination of the terminals and non-terminals. I will explain it what it is. First let me write it. The combination, I'm just writing COMB, of terminal and non-terminal. I hope it's visible. Yes. So let's consider this example only. So we are going to write the transition function or the rules for the PDA. So the very first rule is going to be, so we have to write rules for the terminals as well as for the non-terminals. So let us first understand, or let's see what are the terminals and non-terminals. So here the terminals, if I write the set of terminals, it is only S. We can see that, I'm sorry, not the terminals, non-terminals. So here the non-terminal is only S. Non-terminals are the one which are represented by the capital letters. So we can see that only the non-terminal we are having is the capital S. And the terminals which we are having, terminals are denoted by the small letters. So these are A and B, small a and small b. So now we have to write the production rules for both of them. So first understand how to write for the non-terminal. So for the non-terminal in the RHS, we are going to write the present state. Let's consider the present state is Q naught. Okay. After that, we are going to write the input. So in whenever we are writing the production rules for any non-terminal, here it is S. So remember that the input symbol is always going to be our epsilon. Just remember that. And after that we are going to write the top. So top is going to be the non-terminal symbol for which we are writing. So here it is S. So this has been the LHS. Now we are going to write the production, the RHS. So the next state, so next state is going to be the same as the present state, so it is going to be Q naught. And after that I have written the combination of terminal and non-terminal. So here we are writing for this rule. So here the RHS, on the RHS we are having the combination of terminal and non-terminal. So we are going to write it completely as it is. So we are going to write ASA. So this is the very first rule we have written. Now continue this for the second rule for this one. Uh, how many production rules we have, it doesn't matter. We have to write the rules for all of them. Okay, so now we are going to write for the second one. So again, we are not going to change the state. If we were in q naught, we are going to remain in the same state. And again, the input symbol I mentioned, for every non-terminal it is going to be epsilon. And again, the top would be s, because we are writing for s, the LHS is still s. Now it will produce again the same symbol in which we are. Now on the RHS we are having the combination of BSB, so we are going to write BSB. I hope it is clear. Now moving on to the third and the fourth. So again, the present state is this, then epsilon and capital S, it produces again on the same state. And RHS, we are only having this terminal symbol small a, write this. Okay, now moving on to this one. So the present state is this, we will read only epsilon, then capital S produces again on the same symbol, and small b. So now we are done for the non-terminal symbols. We had this four production rules. So we have written four transition function, or the four production rules here also. Now we have to do for the terminals also. So for in case of terminals, we have to identify how many terminals we are having. So here we are having only two terminals, which is A and B. So we have to write only two production rules for this terminal. So now when we are writing terminals, just remember that we were in the same state q naught. Now instead of reading epsilon, in case of terminals, when we're reading terminal, you have to read that terminal symbol. I'm writing for small a, so I will read small a. And after that we have to write the top of stack. So top of stack is also going to be the small a. And we are going to pop, whenever we are writing production rule for the terminal, we are always going to pop that symbol. So it is going to be q naught, on the same state we are going to be, and we are going to pop. And whenever we pop, we write epsilon. Right. Now we have done for terminal A. We are going to repeat the same for terminal B symbol also. So q0 b, we will read b, the top of stack is b. Then production rule, we are going to be in the same state q naught, and again going to pop that. So here we have written 1 2 3 4 5 6 production rules. So we have constructed the PDA. These all are the transition functions or the production rules in terms of PDA. So we are done. Thank you, friends.